One of the things that we get a lot of questions about is what happened during COVID and how our immune system works and how vaccines work with all of that. So we're going to take a minute and do another analogy, a quick thought experiment. So most people in our world understand how law enforcement works and what they do. And that's going to be our analogy here. We're going to have law enforcement officers. And you know that a general patrol officer is riding around in the neighborhoods looking for things that seem unusual, that seem to not belong in the place that they're at. And they'll stop and they'll try to figure out what those things are. So you have an immune system with patrol officers that are riding around and they're looking for something that seems out of place. They may go through Hotel Lung and find a bunch of people there, a bunch of tourists that have come in from the outside. And one of those guys is wearing a pink shirt and another one's wearing a green shirt, another one's wearing a blue shirt. Nothing looks weird, so they move on. They move through the rest of the body. They make another patrol through Hotel Lung, and all of a sudden they have 5 guys with pink shirts. And they're like, well, there's a lot of pink shirts, but maybe it's a convention. Let's keep going. Let's go through the body again. And now they come back, and there's 50 guys with pink shirts, and they're getting calls over the radio that there's pickpockets and things are happening at Hotel Lung. And they're going to stop, and they're going to try to figure out what's going on. And they find that these guys in the pink shirts are wearing hats and pink shirts, and they're picking people's pockets. And now they have a problem. So they're going to start taking those guys, they're going to arrest them, they're going to take them out of play. But the other thing that they're going to do is they're going to call back to their desk sergeant. And they're going to say, hey, Sarge, we've got a bunch of guys here at Hotel Lungs. They came in from the outside. They're wearing hats and pink shirts, and they're picking pockets. And we're really concerned about that. So the sergeant is going to say, hey guys, it looks like we have a problem. He's going to call a bunch of officers in, and they're going to create a pickpocket squad to go out and find those pickpockets and snatch them up and take them out. This squad isn't going to be looking for anybody doing painting on the sidewalk, isn't looking for anybody breaking into a car. They're not doing anything else. Their whole purpose as a squad is just to look for and take out pickpockets. So this analogy is sort of like what we're looking at with an immune system. You have general immune cells that are always going through your body, and they're looking for things that seem to not belong, particularly pathogens from the outside. So a lot of times you'll find them in your lungs, you'll find them in your gastrointestinal system, ways that were easy to get from the outside. And they'll be looking for things that don't belong so that they can take them out. But they're not necessarily going to see those things the first time that they drive past, because you can't tell that something's out of place until things start to go a little sideways. So they're going to maybe go past, and you're going to have a delayed immune response because the cells are not specialized and looking for particular targets. A lot of times it's the protein coats around these pathogens that they're going to be looking for. So they're not going to see that. They're not going to see the pink shirt as a problem right away because they're not specialized. They'll go around and then they'll realize this thing's gotten kind of out of control and now we have too much, and they'll start taking them out. When they take them out, they're going to send a call to your immune system and they'll create specialized immune cells. The Vi squad, the pickpocket squad that's out there going and looking for pickpockets only. They're not going to be looking like the generalists did to see if somebody's breaking in or jacking a car or whatever. They're just going to be looking for those pickpockets. They're keyed to that protein coat or that particular chunk of virus that's telling them, hey, this is the problem. They're much more efficient at finding that specific problem. Maybe you're going to get a flu vaccine. There are many different strains of flu, and maybe that's like having a pink shirt, a blue shirt, a yellow shirt, and a red shirt. Maybe this year we're looking at pink and red shirts, and that's the flu vaccine that we put out. But what we actually have are blue and green shirts. Now we have them not recognizing and immediately snapping up those blue and green shirts because they're looking for pink and red shirts. But they do recognize that they're the flu. So they're going to be a little bit delayed, and so you may get a little bit sick, but your illness is going to be less severe and it's going to be it's going to have less duration. So that's an important part to recognize with this, that sometimes when you hear people say, oh, I took the flu vaccine and I still got the flu, that may happen, but it may not be as bad severity, and it may not last as long because your immune system was able to snatch it up before it took over and replicated as much throughout your system. So when we look at different kinds of vaccines, those vaccines are going to be creating those specialized squads that don't look for any other disease, but those white blood cells are keyed in to the one disease that it's been primed to take. You get those that disease information through the what they put into the vaccine shot. So that vaccine gets usually it's inactivated, and it's telling your immune system this is a threat, so that it creates those squads that are always patrolling with a specialized key to look for measles or chickenpox or rubella. Now, one of the other things that we should talk about is vaccines and how they came to be so quickly to the market in COVID-19. So I want you to do another thought experiment with me and think about one of those one-armed bandit gambling machines, the slot machines. And if you've ever seen those have a bunch of wheels, and the wheels have a ton of pictures on them. So let's say we have a whole bunch of fruit on our pictures. So let's say our vaccine is 100 wheels long. Our slot machine is 100 wheels long, and it's got 10 pictures of fruit on it. If you were to try to create and get the winning jackpot, you'd pull that slot machine and you'd have to pull it thousands of times before maybe you got the jackpot. But what happened in COVID was that they set a lot of the wheels to already be winners. So if we had 100 things in our recipe, we set 98 of them because we already knew what they were. Many of you probably used shampoo or shaving cream or deodorant or even makeup before you came here. I don't need to know. But all of those things, if you look at the bottle, it says not tested on animals anymore, because all of those things have recipe books. And the FDA has said, if you pull from the recipe book and you stay within the thresholds of safety, all you have to do is tell us what the recipe is, and you don't have to test on animals again. So we don't go through the long, expensive, and concerns about animal cruelty have been set aside because they stay within the recipe book. The same thing can happen with shots. With COVID, COVID is SARS-CoV-2, coronavirus 2. We had SARS-CoV-1. We've also had MERS, Middle East Respiratory Syndrome. Those are viruses like the viruses that are in pink shirts, blue shirts, and red shirts. So we know that they're pickpockets. We know that they are wearing hats. We know that they're all male, say. But what we had were different color shirts. So they had fixed all of those things in the recipe because they'd used them before. And they only had to find the one little pieces from the shirt color, in this case, the difference between SARS-CoV-1 and MERS and SARS, to be able to make a vaccine for SARS-CoV-2. That's how it got to market so quickly. They already knew most of the recipe, and they didn't have to go back and test it from the beginning because they had fixed that recipe. They just had to find the small part that was unique to that one disease. It made it go much faster, and then they created an expedited testing program to make sure that that change didn't create adverse medical effects, and they were able to get it to market quicker. All right, thanks for playing with me on that thought experiment. I hope it helps, and let us know if you have any questions.